So I'll talk about the equipment we use quite quickly. This is a 1.8 meter dish that is our main dish for the 21 centimeter instrumentation. You can't see it here, but there's a circular waveguide feed horn, some amplifiers, filters, and then about 70 meters of cable that connects it to the laboratory. And in the lab, we have the receiver here. It's 2 channels. So when the sky map that I'm going to show you was made, we simply fed a duplicate signal into the 2 channels of the receiver, which actually improves the signal to noise ratio ever so slightly, because you're getting 2 independent observations of the same phenomenon. So you get a little bit of an improvement. So what is it that we're actually doing? We're measuring, we're taking spectra of the sky over the galactic range of the hydrogen line. So roughly plus minus 160 kilometers per second in Doppler. And this is what one of the raw spectra looks like. You know, the axis isn't even labeled particularly interestingly here, but this shows you what the raw data looks like. There's a chunk of radio frequency interference right there. That's actually an artifact of the precision clock that we use. It runs at 10 megahertz, and this is the 142nd harmonic of that, which shows up quite nicely in our data. So later on, we remove that. That's the hydrogen line right there in this particular part of the sky. I think this was this was taken around 20 o'clock LMST, a declination around plus 50. So, you know, higher in the sky a bit. What we do, we chop it off here, and we also do some other things to the data. So here's what the same sort of thing would look like after the spectra has been processed, or the spectrum has been processed, or one of the spectra. We blocked off the edge roll-off that was the blue lines in the previous image. We removed the slope. I don't know if you notice that there's a distinct slope to the spectra. That's an instrumentation artifact, which is pretty much constant throughout all the measurements we take. So that has to be removed to get a better estimate. We removed that little chunk of RFI right there. It's more or less down in the noise there. And then we convert this into a very, very rough temperature estimate based on what we know about the character of hydrogen across most of the sky. So then what do we do?
One more.
Yep. Then we make one of these. So for each of those spectral records, we calculate the total power across the entire record after we've done all of those corrections and so on. And then we plot it in a grid with colors representing the apparent brightness more or less. So that's what we have here. So this was roughly 5 or 6 months worth of data with the single polarization instrument. And about 2 months ago, we upgraded the instrument to dual polarization and slightly better low noise amplifiers. So what we hope to do is I'll have another talk maybe in another couple of months where we have the same data but recorded in 2 polarizations, which increases the sensitivity because you're basically looking at twice as many photons, more or less. So I know Rob was complaining at me that the RA axis was in the wrong direction, and I haven't fixed that yet. We can basically see up to about plus 70 with our instrument, maybe plus 75, and down to about minus 35, which if we were on the ground would be quite close to the horizon, but we're up on a roof. We're about 10 meters up, and that actually improves the amount of horizon we can see. So we actually do have coverage all the way down to about minus 35 here. We may be able to push it up to plus 75 as well. So you can see what the sky looks like in hydrogen. The brightest parts are, no big surprise, the galactic plane. Up around here in Cygnus, it happens to be particularly bright. And surprisingly enough, And I remember when I first read about this, it's actually not as bright towards the galactic center. That was, I mean, I'd read about it, but when you actually see it in the data, where down here, it actually starts to dim a little bit. And you actually see it in the data, it's kind of neat. So the dual polarization work probably be ready in a couple of months, and we'll have even more detail in this. The gridding here is roughly 5 degrees on the side, and I use a bunch of techniques to produce this, like Gaussian interpolation and so on, to produce a reasonably nice image.